We were asked to develop a test fixture that would measure the force required to insert a laparoscopic device into a trocar. At first glance, this seems easy. Just place the device in a test frame and measure the insertion force. However, the problem becomes more challenging when you consider possible differences in manufacturing and how measuring devices which displayed such differences might alter the device performance and thus the accompanying test data. For example, let's say we have two laparoscopic devices, represented by the blue shaft, that need to be tested in a trocar, represented by the red object. Device 1 has been manufactured with a perfectly straight shaft, while device 2 has a slight angle to its shaft, maybe only a degree or two. But now your force data will be different measuring device 2 versus device 1, because due to the angle, you won't be measuring purely insertion force. Now you will also be picking up a small side load due to the angle of the device's shaft. This is a great example of how a fixture, if not designed well, can effectively alter the performance of a device. To ensure ours didn't, we needed to design the fixture such that it mimicked a surgeon's hand, which in practice adjusts in real time and, by the way, without any real conscious thought on the part of the surgeon, to accommodate things like imperfect shaft alignment. In other words, the surgeon's hand simply articulates as needed during insertion to ensure the device shaft slides straight into the trocar as opposed to at an angle. To replicate the surgeon's wrist articulation, we incorporated a gimbal mechanism, the parts shown in green, that allowed for rotation in two planes, and we incorporated a planar sliding feature, the pink part. The two rotational degrees of freedom coupled with the planar sliding offered all of the degrees of freedom in motion that a surgeon would simply intuitively provide during the procedure, and allowed us to then measure the pure insertion force without the artificial side load resistance that would have been present had we designed a fixture that excluded these accommodations and thus erroneously picked up the side load resistance in its measurements.